Hi guys, we're in Unit 6, Day 4 Notes, Rational Exponents Part 2. So this is the second day of this. Okay, in this first box, or I guess technically the second box, it says what is the difference between radical form, that's this stuff over here in yellow, and then exponential form, exponential over here in green. Really, they're the same thing. It's just a different way to rewrite this. So as you're looking at this really carefully, radical form is with a root. You have a little number, kind of, I like to say, sitting on this little ledge here. That number ends up being the bottom of the fraction in exponential form. The m, that little number on the outside, ends up being the top number of the fraction. So if you want to see this with an example with actual numbers here, the little 5 sitting on the ledge becomes the 5, the bottom of the fraction. The 7 on the outside becomes the 7 on the top of the fraction. And it just follows that pattern. You're not really changing anything. It's just following that pattern. Let's see, these first couple examples, let's look at them. Let's try to keep that up on the top there. It says, example 1, rewrite the expression in exponential form. So I have radical form. It's in radical form because it's a root. It starts as a root. Then I'm going to exponential. So I just follow this pattern up above. The little 3 on the outside is going to become the bottom of my fraction. And then the 4 here is going to become the 4 on the top of my fraction. And that's it. It just follows that pattern. This next one, you can envision if there's no number hanging out there on the outside, is technically a 1. So I have y to the 1/5. Then I have 3 to the 5/4, just following that pattern from above. Then I have -2, let's keep it in parentheses, to the 5/3, just following the pattern from one to the other. Now we're going to go the exact opposite way. I have exponential form. I'm going to rewrite it in radical form. So now this little 5 that's on the bottom is going to become the 5 that sits on the ledge of my root. The 4 stays there. The 2 comes to the outside. The next one, the 8 comes to my little ledge. The -7 stays underneath. The little 5 comes to the outside. My third one here, the 6 comes to my ledge, the z stays under. Technically I have a little 1 there. If you want to leave it like that, it would not be wrong. You don't have to put the little 1 there, so you could also leave it like that. My next one, the 7 comes to the ledge, the x and the y go under, and the 6 is on the outside. If that was confusing, take a second, pause the video, maybe erase, try them again. Look at the forms up top. That'll definitely help you. Moving on. It says in this chapter, we will now always. Step 1, do what you can in exponential form. That's from Day 3 notes. Step 2, then switch to radical form. That's what we just practiced. Step 3, and then simplify the radical form. We're going to do that in a couple days. We'll eventually get there. Simplify and write in radical form are the instructions, problem 3 here. As I'm looking at this, I'm thinking back to what we did the other day. What we did the other day is took that negative exponent and moved it to the top. That's the same. So I have m to the 2/5, and the other m to the 2/5 comes up to the top. Now they're right next to each other. Now that they're right next to each other, I want to add my exponents. So let's write that down. Add exponents. When I add my exponents, I get m to the 4/5. That's great. However, that is in exponential form. I want to take exponential form and I want to rewrite this into radical form, which would be 5 sitting on the ledge, m underneath, 4 on the outside. Okay, so this is confusing. This is exponential form right here, the first one, and I rewrote this into radical form. Radical form. That's what the question is asking. Do the simplifying, get down to your answer, and then write this in radical form. That's what we did. The next one, the a to the 1/4 times a to the 3/5, those are right next to each other. Those are good to go. Let's add those exponents. When I add those exponents, I get a raised to the 17 over 20. I want to take that exponential form and turn it into radical form. So the 20 sits on the ledge, the a goes underneath, the 17 is on the outside. Problem 5. I have a little issue here. This negative exponent, I don't like it. Actually, they're both negative. I don't like them. I want to move them to the bottom. When I do that, I have 1 over x to the 3/5, x to the 1/5. Now, I want to add my exponents in that blue part there that I highlighted. When I do that, I get 1 over x to the, 4/5. Okay, but I want it in radical form. The 1 is going to have to stay. On the bottom, I have the 5 on the ledge, the x on the underneath the radical, and then the 4 on the outside. Problem 6. What I like to do here is the same as before. I take that and I distribute it in. Let's see what I get. I get x to the 2/3, y to the 1/3. X and y I cannot combine, so I'm going to go ahead and rewrite this. When I rewrite this, I'm going to have a 3 on the ledge, an x under, a 2 on the outside. Then I'm going to have a 3 on the ledge, a y under, a 1 to the outside. I'm totally fine if you guys leave it like this. You could condense this, and you'll kind of learn about this in a little bit. You could condense this to 3 on the ledge there, an x and a y underneath. Okay, oops, sorry, I forgot the x squared, and then the y underneath. I just forgot my little 2 there. This is the exact same thing. Doesn't matter. They're the same. You wouldn't get them wrong. They mean the same thing. Problem 7. Let's see here. I'm going to do some distributing, top and bottom, just like we practiced before. I get 4 to the 1/3, and then I get 5 to the 2/3. Let's rewrite this. That becomes a 3 on the ledge there, a 4 underneath, a 1 on the outside. Then a 3 on the ledge there, a 5 underneath, a 2 on the outside. I'm fine. Again, leave it like that, no big deal. Let's do an or. Or you could write this as a 3 root there, 4 to the 5 squared. Because they're both to the third root there, you can kind of expand this and make this a little bigger. You could even take this and rewrite this as the 3rd root of 4 over 25. That is really confusing to you right there. That's fine. Forget it. Don't worry. Stick to the way that we did it before. But if you're ready for that, you can also rewrite something like that. Problem 8. Almost there. I'm going to distribute that in. When I distribute that in, I get a to the negative 6 over 7. Took me a second to think about that one. Negative 6 over 7. Then I have a negative exponent. No good. Let's get rid of that. Let's move it to the bottom. When I do that, I have 1 over a to the 6 over 7. I want to rewrite that piece. 1 over 7's on the ledge, a's under, 6 is on the 7's on the ledge, a's under, 6 is on the outside. And then I'm good to go. Last one here. Let's distribute just like we've been doing to all the pieces on the inside. I get x to the negative 2/7, y to the 6/7. I don't like that negative exponent, so I'm going to move it down to the bottom. I get y to the 6 over 7. And then I have x, now it's positive, 2/7. I can't combine x's and y's. So my y's on the top is just going to have to stay. The x on the top is just going to have to stay. But I can rewrite this from exponential form to radical form. Rewriting this, I get 7 on the ledge, y underneath, 6 on the outside. Then I get on the bottom, 7 on the outside. 7 on the ledge, x underneath, 2 on the outside. Again, I'm totally good if you leave it like this. Or, if this makes sense to you, you can kind of make this a big radical, the 7th root of y to the 6 over x squared. This is the same exact thing. You can write it either way. If you are confused, go back and look at your exponent properties from the very first day. Those are super important. That's what makes this stuff a little bit easier and go a little bit better if you're comfortable with those properties. If I went too fast, please pause, rewind, go back, watch the video again.